Hey guys, if you're just starting off with trigonometry, this style question's pretty common. We've got more advanced ways of solving this one, but if you're just starting off with some of the basic rules, sine, cosine, tangent, without getting into the actual cosine rule, sine rule, there's a number of different ways that you can approach this, but what we're looking at here is probably one of the more complex style basic trigonometry topics that we've covered. So hence a bit of a strange title for this one. But when you look at this little diagram that's been provided to us, it's actually two right angle triangles overlapping. So what I've done is I've gone ahead and drawn both of those, and the final idea here that y is going to be equal to the height plus the actual height of the observer. Sometimes we do this one with ships in the harbour and the distance between the two of them and how far apart are they from a cliff, or how high is the cliff based on the distance and the viewing levels. This one here might be that an observer at this point here, being 189 centimeters from the ground, that observation point, looks up, sees the top of a building over here in the distance, walks another 75 meters to get closer to it. This is the new angle looking up to the top of the building. So I'm going to go ahead and write an expression for h using both of these. I haven't got a hypotenuse, so whatever I'm using today is I'm going to be using tangent ratio for all of these, and tangent is equal to the opposite over the adjacent. So let's go ahead and put these values in. Let's say in triangle A, substituting values, tan of 43 degrees 35 minutes is equal to the opposite, which is h over x. So I need an expression for h is what I'm looking for. So therefore h is equal to x times the tangent of 43 degrees 35 minutes. Alongside here I'm going to do in triangle B. The tangent of 32 degrees 18 minutes is equal to h over x plus 75 meters. Again, I just need the expression in terms of h. h is equal to x plus 75 lots of tan 32 degrees 18 minutes. Okay, so now that we've got two expressions for h, we can go ahead, call this expression 1, call this equation 2. We can go ahead and now write that this is actually equal to this value here, because they're both the height of the building. So the height of the building is equal to x tan, I'll write a bit clearer for you this time, 43 degrees 35 minutes, which is equal to x plus 75 of tan 32 degrees 18 minutes. I'll just go ahead and solve for x here. I might just distribute this first of all, because then I can do a bit more with it. This side, this left-hand side, I'm doing nothing with. I will leave it as is. And I want to get all of my variables, my x, onto this left-hand side. So if I expand this, I've got x tan 32 degrees 18 minutes, and I'm going to add to that 75 lots of tan 32 degrees 18 minutes. Okay, so I'm going to take away this from both sides, the x tan 32 degrees 18 minutes, and I get x tan 43 degrees 35 minutes, and I'm going to take away from that the x tangent 32 degrees 18 minutes, and that's going to equal this constant over here. Just because you're seeing tan doesn't mean there's any variables over here. This is just a constant. Okay, back to my left-hand side. I'll move this up a little bit. Back to the left-hand side here, I'm going to factor out x, and so I'll just have tan 43 degrees 35 minutes, and that's take away the tan of 32 degrees, 18 minutes. I'll leave it like that for now. Again, nothing happening over here to this side, so I'll just rewrite that. And the last thing I need to do now is I'm going to divide both sides by this big mess here. X equals 75 tan, 32 degrees, 18 minutes, divided by tan, 43 degrees, 35 minutes, minus tangent, 32 degrees, 18 minutes. Key that away in the calculator, and I'm going to get a value that's approximately equal to 148.37. Our units are in meters. So I've now got an idea based on this story up here. Walked 75 meters towards a building. We can now know that the distance from this observer at the second point to the building is 43 meters and 37 centimeters roughly. Okay, it hasn't actually answered probably the point of this question is what is the height of the building, and strangely enough the question gave me actually this value h, whereas the height of the building is actually y, but we'll play around with that a little bit more now. So now that I've got an expression for x, I can substitute it back into one of these two equations and get my value for h. This one is a lot cleaner than the second one, so I'm going to go ahead and use that. So in equation 1, h is equal to, if I want to be exact, I could put that whole mess back into it, but I've still got that sitting in my calculator, so I'll be able to use that anyway without any rounding. Dot, 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 to say that that continues, multiplied by the tangent of 43 degrees, 35 minutes. And that works out to be approximately equal to, h is approximately equal to 141.21. So again, the variable h wasn't actually the height of the building. Right back at the very top over here, I worked out that y was equal to h plus 1.89, the height or the eyes of the observer at the point where it was being, the building angles were being measured. So I now need to answer the question by putting in that y equals 141.21 plus 1.89 roughly, and this works out to be y being 143.10, again meters. So now I have actually worked out the height of the building. So the question actually just gave me pronumerals, but if it was a word-based question, I would go ahead and say, therefore, the height of the building is 143 meters, 10 centimeters. Okay, I hope you like that. Let me know if I can make any other adjustments for you or clarify anything for you. I'll probably show you another way in the future about how we can do this using a few other tricks. Thanks for watching.